Hello everyone, welcome to the next session on finite element analysis. In this session, we are going to discuss the applications of FEA. FEA is a versatile and widely used computational tool with applications across various engineering disciplines. Some common applications of FEA include structural analysis. FEA is extensively used in structural engineering to analyze and design components and structures under various loading conditions. It helps determine stress distributions, deformations, and failure points in materials. For structural engineering, we can take examples of bridges, dams, beams, columns, and many other mechanical components like connecting rod, a piston ring, a leaf spring, gears. All these come under structural analysis. So here you can determine the stress distribution and deformation over the body. You can also figure out where your material is going to fail. Say you get some colored results. Wherever you find the color red, that is a zone where you will generally find that the value is higher. So at that spot, you will figure out that there is failure point over a material. Mechanical components and systems. FEA is employed to analyze the performance of mechanical components and systems such as gears, bearings, springs, and linkages. It aids in optimizing designs for strength, durability, and efficiency. When you analyze these systems, you can figure out where the material is going to fail, and then accordingly you can determine where the object is going to fail, and accordingly you can give it, say, extra material, or you can give better material such that the object is going to sustain for a longer life. Aerospace engineering. In the aerospace industry, FEA is crucial for analyzing and optimizing aircraft structures, wings, fuselages, and components. It helps ensure the safety and reliability of aerospace systems. When we talk about aerospace engineering, all these objects that we have mentioned here are very crucial and they need to be analyzed beforehand such that you can avoid any kind of mishaps that can happen. If you remember the Space Shuttle Columbia disaster, which was a fatal incident in the US space program that occurred on February 1st, 2003, when the Space Shuttle Columbia OV-102 disintegrated as it re-entered the atmosphere, killing all the 7 crew members. During the STS-107 launch, a piece of the insulative foam broke off from the space shuttle external tank and struck the thermal protection system tiles on the orbiter's left wing, destroying the internal wing structure, which caused the orbiter to become unstable and break apart. Safety of wing was ensured on the basis of only computational dynamic analysis, that is CFD. So had it been more analysis done on the wing structure and also on the body, then this kind of a mishap could have been avoided. It is not only about the space shuttles, it is also about the passengers who travel day in and day out. There are innumerable flights flying around the world every second. So the life of so many passengers are always at stake. So aerospace engineering is a very crucial part of study of FEA analysis. Automotive engineering. FEA is used to analyze and optimize automotive components and structures, including chassis, suspension systems, engine components, and crashworthiness simulations. So all these things are again very important, like aerospace, because automotive is another industry which is widely spread. Everything you need to travel, apart from something which is there in the air or on sea, is a part of automotive engineering. It could be buses, trains, auto rickshaws, cars. Everything is a part of automotive engineering. So analysis of each of its part is very important such that the life of the people is not put at stake. We have already discussed that safety and reliability are the two main advantages of FEA, and that is the reason why we go for FEA analysis before preparing the actual model. The next one is civil engineering. FEA is applied in civil engineering for analyzing and designing structures such as bridges, buildings, dams, and tunnels. Now, when I told you about structural engineering, I told you about civil engineering and mechanical components combined over there also. Because structural engineering is a broad term, and all these things which you see under civil or mechanical are also a part of structural engineering itself. It helps assess the structural integrity and stability under different loading conditions. Heat transfer analysis. FEA is utilized to analyze heat transfer in components and systems. This includes studying temperature distributions, thermal stresses, and designing efficient cooling systems for electronic devices. This is something which is very widely spread these days. I have created n number of videos on all these topics, so you can just go through them such that you get an idea of what kind of ANSYS analysis can be done on all these types of components, and it will give you a better understanding of FEA in general. Fluid structure interaction, FSI. FEA can be used to analyze the interaction between fluid flow and solid structures. This is crucial in applications such as the design of underwater structures, offshore platforms, and medical devices like heart valves. So say if you're talking about a heart valve, you can analyze what will be the interaction between the blood and the walls of the heart, such that you know what is the pressure exerted by the blood on the heart valves, whether the person is suffering from some kind of blood pressure issues, or it could be some kind of blockage in the heart and enough pressure is not generated by the walls of the heart. It could be some kind of a stiffening of the walls of the heart. So such kind of analysis can be done by using ANSYS. You can have underwater structures. For example, you can have some submarines. You can see what is the effect of the fluid around it, that is seawater, on the structure. You can have some offshore platforms. For example, you can have a dockyard where you bring your ships for maintenance. So what could be the effect on the ship model of the water which is held inside it? So all these things can also be studied. Fluid structure interaction is extremely important because you also come to know about, say, a building that you have created which is very tall. So what will be the effect of some kind of cyclone if it comes in that zone, and how it will affect your building, and say if there could be some kind of crumbling of the building because of such kind of a storm or something, you can just analyze beforehand. So in the parts of the country where there are cyclone effects, or there could be some kind of storm which keeps on coming every now and then, so what would be the effect can also be studied, because it is all about a fluid and a structure. Electromagnetic field analysis. FEA is applied in the analysis of electromagnetic fields, helping engineers design and optimize electromagnetic devices such as motors, transformers, sensors, and antennas. This is another field of engineering where you can apply FEA and you can study about all these components. Biomechanics. In the field of biomechanics, FEA is used to analyze the mechanical behavior of biological structures such as bones and joints. So you can study what is the structural analysis of a bone by analyzing if there is a fracture in the bone and what would be the load that the bone can sustain after fracture, or say in general how much load the bone can structure, and if there could be some bending and all over a period of time, what is the effect of load on the joints of a patient. Or you can study some thermal analysis, some kind of modal analysis. So all these things can also be done by using FEA. It aids in understanding the impact of forces on the human body and helps design medical implants. So you are very much aware of the compression bone plates which are used for holding the bone in place in case of fracture such that it heals. There are screws and plates which are used. There are certain rods also which are implanted at times. So all those things can be designed if you analyze using FEA and you know how much load it can bear after fixing such kind of implants. Thermal analysis in electronics. FEA is employed to study the thermal behavior of electronic components and systems. This includes analyzing heat dissipation in electronic devices and optimizing their thermal management. These days, cooling pads are used along with the laptops, because over a period of time we have come to use laptops which emit a lot of heat, especially if you're using a gaming laptop for gaming purpose or for any other kind of analysis or any in general use. So since the heat lost by the laptop is too much, sometimes the laptop starts getting overheated. So you need to have cooling pads to remove the heat and help proper functioning of these laptops. So these kind of analysis of these cooling pads can be done using ANSYS. Also, there are fins which are attached to various electronic devices such that they are able to lose heat. So you can do analysis of those fins also using FEA. Optimization studies. FEA is utilized for optimization studies to find the best design parameters that meet specific performance criteria while minimizing material usage or weight. So you can optimize your design by using FEA, and you can then go for manufacturing, testing, validation, and finally use in the market. Acoustic and vibrational analysis. FEA helps analyze the vibrational and acoustic behavior of structures. This is important in designing components to minimize noise and vibrations in applications such as automotive and aerospace. You must have seen that automotive and aerospace are zones where you have a lot of noise and vibration generated. So you can analyze the amount of noise generated and how you can go for better structures in that case to avoid the noise, and also it applies for vibration. Geotechnical engineering. FEA is applied in geotechnical engineering to analyze soil structure interaction, slope stability, and foundation behavior. So in case you want to study the effect of soil structure interaction, you can go for FEA analysis. Say you want to know what kind of a slope would be perfect for a particular structure, you can also use FEA analysis in that case. And foundation behavior is where you create a foundation and you want to know what load can be held by the structure, or if there is a earthquake, you can also analyze what would be the effect on the body. So that's nothing but a seismic analysis that you do. Now we'll talk about the key points of the session, the takeaways from it. The applications of FEA are diverse and its use continues to grow across various industries as computational power and software capabilities advance. It enables engineers to simulate and analyze complex physical phenomena, leading to better informed design decisions and improved product performance. So this is something we have been discussing all over from the start, where we are discussing about the advantages and also some disadvantages which FEA has. So you need to understand that the application of FEA is really vast. All the domains of study can be incorporated into FEA analysis. You can figure out the best possible design, what could be the life safety factor, and then you can go for marketing of your product once you manufacture and test it. Products which go through FEA analysis are always going to be better than just designing them and going for destructive testing all the time. Only destructive testing doesn't help, because you invest a lot of money and you are just wasting that money, because all the material, the labor, the time is just lost. But FEA analysis will help you bring down an optimized design, a solution by saving your money, and you can get better results. So with this, I end the session. I hope you have understood the lecture. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.